Hello and welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is rotations on a coordinate plane. Let's get prepared for today's lesson. We will need a pencil with an eraser. We'll also need some paper to take notes and also some graph paper since we are working with transformations. A ruler or a straight edge is optional for today's lesson if you would like to draw straighter lines. And don't forget to pause the video from time to time to try to answer the practice questions on your own before receiving the answers. That's the best way to learn. And if you would like to rewind the video at any time to review something before you try to answer the questions, that's perfectly fine. So before we get started on today's lesson, I'm Miss G and I'm your teacher. We're going to do 3 deep breaths just to try to clear out our mind and get it ready and focused to try to learn about more of these transformations on a coordinate plane. We're going to breathe in our nose and then we're going to breathe out our mouth and we're going to hold it in for 3, a count of 3. So let's breathe in our nose, hold it, 1, 2, 3, breathe out your mouth. Let's breathe in our nose, hold it, 1, 2, 3, breathe out your mouth. Okay, again, breathe in your nose. Hold it, 1, 2, 3, breathe out your mouth. Good. Now let's go over some of the vocabulary terms that we're going to be using in today's lesson. Our first vocabulary term is going to be a coordinate plane, which is what you're looking at right here. It's a grid or graph type pattern divided into 4 sections by 2 axis lines, the center point in the middle being the origin. Transformation is a process by which we change a geometric shape, a line, or a point, or a line segment by changing its orientation or its location on the coordinate plane or its size. The origin is the center point on our coordinate plane, which is the point 0, 0. The x-axis is the horizontal axis, which runs from right to left or left to right. And the y-axis is our vertical axis, which runs top to bottom or bottom to top. Ordered pairs are basically how we find our coordinate points on the graph. The x value tells us how far left or right to go. The y value tells you how far up or down to go. And it's always listed in alphabetical order with the x value first and the y value second. A rotation is a type of transformation that we're going to study today, and it's also called a turn. It's when we turn a shape in a specific direction, and that direction can be clockwise or counterclockwise. So clockwise is in this direction, and counterclockwise is the opposite of that. So it's going to go in that direction around a center point. And we're going to be rotating around this center origin point today, which is the point 0, 0. All right, our essential questions for today, there are 3 of them. The first one is define a rotation on a 2-dimensional coordinate plane. The second one, how do you rotate a geometric shape on a coordinate plane 90 degrees, 180 degrees, 270 degrees clockwise, and also counterclockwise around the origin? The third question, how do you determine which rotation has happened based on a graph or a set of coordinate points? Okay, rotations. So rotations are rigid transformations where a geometric shape is rotated or it's turned around a central point of rotation, which is called the origin. Rotations do change the position and the orientation of the shape, but do not change the size. We measure how far a shape has rotated in degrees, and this is the symbol for the degree, which is the symbol that we use on all of these numbers here around. So like if this was 0 degrees, if I moved it this direction, that's 90 that way, and then another 90 that way, and then another 90. And this is the counterclockwise direction because we're moving in opposite of what a clock hand would move. And then over on the clockwise side, you see how it's moving in this direction. Again, though, each section or each quadrant of our coordinate plane is 90 degrees. So if you count 90, then 90, then 90, and then 90 again, you end up with a full 360-degree rotation, which puts you back where you started. So if you started here and went all the way around clockwise here, you would end up in the same spot if you went all the way 360 degrees. Now, halfway is 180 degrees. And then, of course, 2/3 of a way around is 270 degrees. When we rotate a figure, we create a congruent shape. So again, the size does not change. So we will end up with a rigid transformation, not a non-rigid one. Okay, so here's some examples of rotation. So if you look at this triangle LM or KLMN, I should say, this is the pre-image here, the blue one, and then the green one is the prime labeled image. So that's our after it's been rotated. So I'm looking at this, and just from the graph, without even looking at the point values, I can tell this rectangle here has been rotated 90 degrees in this direction. And this direction is clockwise. So this rectangle has rotated 90 degrees clockwise. Now, if I went in the opposite direction and ended up in the same spot, like if I went this way counterclockwise and ended up in that same location, I would have had to have rotated an entire 270 degrees counterclockwise. So you should know that 90 degrees clockwise is the exact same as moving something 270 degrees counterclockwise. You will end up in the exact same spot. Okay. Also note that when you rotate something 90 degrees, you end up one quadrant over. So notice here when I went 90, it just moved one quadrant up. It was in quadrant 3 and now it's in quadrant 2. Well, here it moved 3 quadrants. It moved here, then here, then here. So when you rotate something 270 degrees, you're moving 3 quadrants around the center point. But when you do 90, you're only moving 1. Okay, here's another one. We've got a triangle FGH, and it has been rotated also. This time, though, it looks like it's been turned this direction because the H is now on the left side and the GH is now on the right side. And before it was on the top and bottom. So if I turned it this way, my H would be on this side. And notice it moved one quadrant this way, and a piece of it was already on the other side, so the piece of it's still on the other side. But this is another 90-degree rotation, which is this time counterclockwise 90. So if I were to turn it clockwise for 3 different quadrants, that would be a 270-degree rotation clockwise. So again, the same as over here, a 90 degrees clockwise puts you in the same spot as a 270 counterclockwise. Well, a 270-degree clockwise puts you in the same spot as a 90-degree counterclockwise. Okay, this third one over here is a 180-degree rotation. Now, this one's a unique one because it does not matter which direction you go. If you go counter or clockwise, counterclockwise or regular clockwise, you will end up in the same exact location. You are moving 2 quadrants to get it to its new location in both directions. So if I moved clockwise or counterclockwise, I'm going to end up in that same spot if I move 180 degrees. So when you're asked to rotate 180 degrees around the origin, usually you're not asked to go in any direction. You can pick either or. Now the arrows down here, looking at the pre-image and then the image, this looks like it turned counterclockwise 90 degrees. So just like this triangle here, that would be the same as going 270 degrees in the clockwise direction. And then this triangle here, the green is the pre-image and the red is the image. This one has also been turned 90 degrees counterclockwise, or 270 degrees clockwise. And then the last one, because it's moved 2 quadrants, I'm knowing that this one is going to be another 180 degrees. And again, with this one, it doesn't matter if you go clockwise or counterclockwise, because you'll end up in the exact same spot. All right, so here are the rules for rotations. Now these rules are a little bit more challenging to memorize than the reflection rules were. So hopefully you did previously watch the translation video and the introduction to transformations video, and also the reflections video. Those were the 3 that you should have watched before tackling the rotations, because these are a little bit trickier to memorize, but once you have it down, it's easy. That's how most math is anyway. Like once you memorize it and learn how to do it, it becomes second nature. So the rules for rotation are expressed in words, math symbols, numbers, or a combination of both. So the first one we're going to talk about is 90 degrees clockwise. So for every xy value, you're going to take the y value and the x value, and you're going to flip them around. But before you flip them around, you've got to change your x to its opposite sign. That's what this negative means here. So here the x was positive, now it's negative. So again, change the sign first on the x, then flip it, because if you flip it around before you change the sign, you might get confused. So go ahead and change that sign on the x first, then flip it around, and that'll give you your new point of where to plot the rotated 90-degree shape. So here's an example. Point M is 4, 5 on the coordinate plane here. And notice we took the x here, the 4, we made it into a -4, and then we flipped the 5 and the -4 around to find our M prime. And again, if you rotate something 90 degrees clockwise, it's the same as doing a 270 degrees counterclockwise rotation. All right, here's another one. This one is the rule for rotating a geometric shape 90 degrees counterclockwise. So in this case, for every xy point, instead of changing the x to its opposite and then flipping it around, you're going to change the y to its opposite and then flip it around. So notice this y here was positive, now it's negative, because we changed the sign of the y, then moved the x and the y around to get our new point. Same as up here, but up here we had to change the x, now we're changing the y. So you've got to remember that 90 degrees clockwise, we changed the x, but 90 degrees counterclockwise, you change the y before you flip them around. So here we have a B point, which is 6, 7, and we are going to rotate that 90 degrees counterclockwise. So to do that, we change our 7 to a negative, then we flip it around with the 6 to create our -7, 6 B prime point. And of course, when you rotate something 90 degrees counterclockwise, that is the same as doing a 270 degree clockwise rotation. So use this rule for both of those. Same with the top here. You can use the 90 degrees clockwise rule for the 270 counterclockwise rotation as well. Okay, so here's 2 more rules for rotations. This one is a little bit easier to remember, I think, and that's the 180 degrees clockwise or counterclockwise move. So all you do when you're changing the points on a 180 degrees clockwise rotation, you're just going to change the X and the Y to their opposite signs. So here they're both positive. Now you've got them both negative. You don't need to move the X and the Y around. You only do that on the 90 and 270 degree rotations. You don't do it on the 180. So on the 180, you keep the X and Y where they're at, but you just change the signs of both of them. So let's look at this point F. And we have a 3, 2. We've changed the signs to -3 and -2 to get our F prime. And remember, this is actually the same as counterclockwise as well. 180 degrees, it does not matter, excuse me, which direction you go. So it's same as counterclockwise. And then the rule for rotating a geometric shape 360 degree clockwise is the same thing. So whatever point you start off with, you're going to end up with that same point because it's basically just going to go around the origin and end up back where you started. All right, so how do you do rotations? Well, unlike reflections and translations, there's really not a very good counting method that we can use when we have a graph. So really the best way is to memorize these rules, find your coordinate points, change your coordinate points to the new image points, and then replot the shapes. So here I've got, if it's a 90 degrees clockwise move, you're going to change the X, then flip the X and Y around. If it's 90 degrees counterclockwise rotation, you're going to change the Y to its opposite sign and then flip those around. And for 180 degrees clockwise or counterclockwise, you're not going to change the X and Y around, but you will change their sign. So you're going to change the X to its opposite and the Y to its opposite. 270 degrees counterclockwise is the same rule as 90 degrees clockwise. And then the 270 clockwise is the same rule as the 90 degrees counterclockwise. That should say rule 2, that should say 2 there. And that should say 1. So that's my mistake there. And I'm talking about this one here. Okay, so write down the image coordinate points. Change the points according to the rule for the specific rotation you're doing, and then plot and label the new image coordinate point. Connect all the points to make the shape. So this is the steps, and you have to memorize those 2 rules. So again, this is the same as rule 2. This one's the same as rule 1, even though I had a typo there. All right, so we're going to start by rotating a triangle ABC 90 degrees clockwise around the origin. So this triangle, we're going to rotate this direction clockwise around the origin point, which is this point in the center. And to do that, we're going to list the coordinate points first that are already here. We're going to change those points, and then we're going to list the new points, okay? So let's go ahead and see what we come up with. I'm going to just put the original points here. So up here at the top, you see A was -6, 8, and then B is -8, 2, C is -4, 2, and then we're going to change those points by changing the X to its opposite sign and then flipping them around, okay? So, or excuse me, Y to its opposite sign and then flipping them around. It should be -8, right? Oh, wait, we're doing clockwise. So we're going to go clockwise. So we're changing the X to its opposite sign and flipping, excuse me. So this X here got turned into a +8 and then flipped around to make 2, 8. This X here was turned into a +4 and then got flipped around to make 2, 4. Same with the -6. It got turned into a +6, then flipped around. So when you go clockwise, change the X, then flip, and you'll end up with the shape here. Now notice on my graph, these are both still congruent shapes. I know they don't look like it, but it's only because my coordinate plane The shapes are normally squares, and this one's a little bit rectangle looking. Notice each little block is like more like a rectangle. So that's why this shape kind of looks a little longer. But if you actually count the units, it's still 4 units across, 4 units across. So it's the same exact shape, even though it may not appear that. So be careful of that. Sometimes your coordinate plane looks a little off. So if you need to double check, just make sure it's 1, 2, 3, 4, 1, 2, 3, 4. And from the bottom to the top of the A is 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5, 6. Now, for the second one, we are going to rotate rectangle DEFG 90 degrees. This time we're going to go counterclockwise, okay? Counterclockwise this direction here, okay? So we're going to go counterclockwise. This was clockwise, counterclockwise. Now notice when we do counterclockwise, we're going to list our points, and those points are the original DEFG rectangle. We're going to change this time our X values, and then we're going to replot the point. So X values are now the opposite sign, or excuse me, I'm sorry, the Y values. We're going to change the Y values to the opposite because we're going counterclockwise. So the Y becomes positive, and then we flip it. The Y on point E becomes a positive, and then we flip it around with the X. The -8 became a +8, and then we flip it. And then the -8 on the G point becomes a +8, and then we flip it around with the X. And these are our new points. And so the rectangle will look something like this. And again, it looks a little weird because of my coordinate plane, but it is the exact same number of units down each side as this rectangle here. This one's 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7. And then of course there's 4 on the edges. There's 4 on this edge. Again, when you rotate these shapes, you are seeing the orientation change as well. So notice the E and the F are on the right side. Now they're on the E prime and F prime are on the top. All right, let's try it on our own, because that's the best way to learn math, is to do the math. So we're going to try to rotate this triangle JKL 90 degrees clockwise. How many quadrants did the pre-image move to make the image? So I'm going to pause, or ask you to pause. I'm going to say count of 3, and then I will show you the answer. Now, if you need to pause at this point and rewind the video and write down those rotation rules before you start trying these on your own, it's okay. Go ahead and use the written down rule. I'm assuming you took notes and wrote these down, but go ahead and use the rule to help you rotate it. And then eventually, after you memorize the rules, then you won't have to look anymore and you can just remember it. Okay, I'm going to pause and do 1, 2, 3. All right, so our new pre-image and image points should look like this. If we rotated it 90 degrees clockwise, we would change the X to its opposite sign and then flip it. So notice this became 8, 5. The K was -1, +1. We changed the X to positive and then flip it, became K prime 1, 1. And then the L was a -5, +1. We changed that X to its opposite sign, and we end up with 1, 5. So our triangle should look like this. And it moved exactly 1 quadrant over this way. All right, your turn to try and grow another blossom. So rotate triangle LMN 90 degrees counterclockwise this time. And then how many quadrants did the pre-image move to make the image? So again, we're going to do this one counterclockwise. I'm going to count to 3. Go ahead and pause it. 1, 2, 3. All right, so the pre-image was 9, 3, 9, 1, and 3, 1. And so we changed this time the Y value to its opposite and then flipped them around. So this became -3, +9. This became -1, +9. And this one became -1, 3. Your triangle should look something like this after rotating it 90 degrees counterclockwise, or in this direction. And of course, it did move one quadrant to the left this time. Your turn to try and grow a third blossom. This time we're going to rotate rectangle, PQRS 180 degrees. So I'm going to put a table up here to help you out so you can list the pre-image points and the image points before replotting the shape. So again, rotate rectangle PQRS 180 degrees. I'm going to ask you to pause. I'll count 1, 2, 3. There's our pre-image points and our new image points. Notice the only thing that changed between the pre-image and the image is the sign. This was a -7, now it's a +7. This is a +10, now it's a -10. And your rectangle should have looked something like this when you're done rotating it. Now notice, this is not a translation because the P and the Q are on top here, but over here they're on the bottom. And so the orientation did change. If it was a translation of a slide to the right and then a slide down, that PQ would still be on the top because the orientation does not change on a translation, but it does change on a rotation. All right, so let's try to grow our fourth blossom. How many degrees and in which direction did rectangle ABCD rotate? And explain how you know. So I would like you to pause and then I will count to 3. So 1, 2, 3. All right, this one was rotated 90 degrees counterclockwise around the origin. I know this because the pre-image and the image points follow the rotation rule of XY is a -YX, and that is a counterclockwise 90-degree rotation rule. The Y's changed changed signs, and then we flipped them around on each of these points. Okay, your turn to try and grow a fifth blossom. So which rotation happened given the following coordinate points for triangle ABC and triangle A prime B prime C prime listed below? Which of the other rotations could have also happened? Okay, so here are the pre-image points and also the image points. And your job is to try to figure out what rotation happened to make those pre-image points turn into those green image points you see there. Could be one of two. There are two of these, which is kind of a hint. So I want you to pause it and I'll count to 3. 1, 2, 3. And so this one is a 90 degrees clockwise rotation because the X value changed to the opposite sign before changing places with the Y. This is also a 270 degrees counterclockwise rotation. If you chose that instead of the 90 degrees clockwise, that's fine. But 90 degrees clockwise would be the most popular answer for this question, with 270 counterclockwise being the alternate. Okay, so let's pause and try to answer the essential questions. Let's define a rotation on a two-dimensional plane. So I will count to 3 in my head. If you guys will pause it and try to answer this one on your own. All right, the answer is rotations are rigid transformations where a geometric shape is rotated or turned around a central point of rotation, which in our case is the origin. Rotations do change the position and orientation of the shape, but do not change the size. That's why it is a rigid transformation. Rotations do create congruent shapes, or shapes that are equal to one another. How do you rotate a geometric shape on a coordinate plane 90 degrees, 180 degrees, 270 degrees, clockwise and counterclockwise around the origin? So here are the steps. You're going to list the pre-image points first. Then you're going to change the pre-image points according to one of the rotation rules. Here are the rules listed. And then write the new image points based on the appropriate rule for the degree that you are rotating. So if you're rotating 90 degrees clockwise, you're going to use this rule and then replot your points. And then, of course, if you have a shape, you'll need to connect the points to make your shape. Now, again, when you're answering these essential questions, if you put it in your own words, that's perfectly fine. The idea is to remember the steps so that you can do this on your own without looking at the rule. Pause and answer the essential question number 3. How do you determine which rotation has happened based on a graph or a set of coordinate points? There are 2 ways to tell what has happened. Sometimes you have a graph and sometimes you have a set of coordinate points. All right, so let's look at the answer for if you have a graph. If given a graph, compare the orientation of the labeled points on the pre-image to the image. Also look to see how many quadrants the shape was rotated and in which direction, clockwise or counterclockwise. So remember, if it moved 1 quadrant, that's typical of either a 90 degrees clockwise or a 90 degrees counterclockwise turn. If it moved 2 quadrants, that would be a 180 degree turn. And then if it moved 3 quadrants, that could also be a 270 degree turn or a 90 in the opposite direction. If given only the coordinate points but no graph, you can't see what quadrant they're in, and you can't see its orientation. So you compare the pre-image points to the image points side by side, and then see which of the rotation rules was applied to the pre-image shape to get the image points. Once you know the rule, you know which rotation occurred. All right, so now we have some vocabulary we're going to look at today to review, and this little cute bunny who are in the blossoms is going to help us out with this. Our first vocabulary word that we talked about was coordinate plane. That's the graph that we move shapes around in geometry, and also transformation, which is a process by which we change a geometric shape by either changing its orientation, its location, or its size on a coordinate plane. And then the origin is the center of the coordinate plane, the point 0, 0. The x-axis, which is our horizontal line that runs along the coordinate plane, and also the y-axis, which is our vertical line that runs up and down our coordinate plane. The ordered pair xy is also how we plot coordinate points. It tells us which direction to go. The x tells us which direction, left or right. The y tells us how far to move up or down, depending on if they're positive or negative. A rotation is a type of rigid transformation in which the you end up with a congruent shape at the end, but you're going to turn a shape with a rotation. It's not a flip, it's not a slide, it is a turn, and it's turning around a central point called the origin in our case. You could turn or rotate a figure clockwise or counterclockwise. Remember, clockwise is in this direction around, and then counterclockwise is in that direction around. All right, so a bouquet of math blossoms have opened up in your mind today. To further improve your language skills, remember to practice by doing your classwork and homework every day. Also, study for 10 minutes daily. Ask for help if you need to from a study buddy or a teacher. Learn from your mistakes and don't be afraid if you make them. I will leave a lot of my mistakes on my videos just so you can see that it even happens to adults who have been doing math longer than you have been alive, most likely. So mistakes are just part of learning math, and we learn from them and we try not to make them over and over. Always do your best and always try. Giving up is never a way to get better. You should always try, even if it's hard. And I'm Miss G, and I'd like to thank you for watching today's Math Blossom video. Our next video in this series is sequences of transformations on a coordinate plane. So that's when we talk about transformations that have done more than one thing. It might have like reflected, then rotated, that kind of thing. So sequences of transformations is the one I would watch next after dilations. Actually, you should probably watch dilations first. Now that I'm thinking about it, here's another mistake: watch dilations first and then do your sequence of transformations, so you'll know how to do those dilations on there. All right, so now it's time for me to say it was lovely teaching you math today. Thank you. Bye bye.